Section 6.1. We're going to spend one more day simplifying that integrin first before we move on to bigger and better things. And I just want to go over a couple of examples today on simplifying some things that we know how to do from the past, but just to bring it back to the front of our brain here. So if I want to integrate in example 1, the x squared plus, or x to the fifth plus 3x squared plus 2x all divided by x squared dx. Again, I'm going to break up this integrin by taking x to the fifth divided by x squared. So I'm going to add my 3x squared divided by x squared plus my 2x divided by x squared dx. We now simplify each term in that integrin. X to the fifth divided by x squared gives us x to the third. 3x squared divided by x squared gives us 3. And the 2x divided by x squared gives us 2 over x dx. Integrating, we can have x to the fourth over 4. This is our original function, remember. Plus the integration of 3 gives us 3x plus 2 over x gives us 2 natural logs of the absolute value of x plus c. A couple things that we can do with this. We can find a common denominator, which would be 4. So we get, I'm going to bring it over here, x to the fourth plus 12x plus 8 natural logs of the absolute value of x plus c over 4. Notice again, I put that plus c out at the end all by itself because it's a constant and we really don't know what that constant is. The only other thing that we could do is, if you remember, we can take this coefficient of the natural log up as our exponent. So we would end up with x to the fourth plus 12x plus the natural log of the absolute value of x to the eighth over 4 plus c. And I only show that because sometimes we like to put it up there as an exponent, other times we just leave it as a coefficient. So you just got to be able to notice and see if that's going to be that way for a multiple choice question. If I take the absolute value of something and I take it to the 8th power, we hopefully know that's going to give us a positive value as well. So I really don't need that absolute value symbol either. So I could rewrite it as x to the fourth plus 12x plus the natural log of x to the 8th all over 4 plus c. I'm going to leave the absolute value there just because of my room. In example 2, this should be a squared, I'm going to take the square root of x plus 1 squared all over x dx and find the integration of that. Again, we're going to simplify that numerator. If I take the square root of x plus 1 squared off to the side, and to square that out, remember we have 2 of them, and I'm going to go ahead and distribute that square root of x. So square root of x times square root of x gives us x. Remember, this is x to the 1/2, x to the 1/2. We add exponents when we're multiplying, common bases. X to the 1/2 times 1 gives us the square root of x, or x to the 1/2, plus another square root of x, plus 1 times 1 gives us 1. So I can rewrite this as x plus, I'm going to go ahead and rewrite that radical as a fractional exponent, and then plus 1. So bringing that back over into my integrin, I have x plus 2x to the 1/2 plus 1 over x dx. Now I can start to separate this fraction out. So to separate it out, I get x divided by x gives me 1. 2x to the 1/2 divided by x is 2 over x to the 1/2. Remember, we subtract exponents when we divide, plus 1 over x dx. We can integrate 1. We can integrate 1 over x. The 2 over x to the 1/2 is our problem. We need to take this x to the 1/2 and bring it to the numerator. So to do that, we're going to have 1, the integration of 1 plus 2x to the negative 1/2 plus 1 over x dx. Now I can go and integrate this. Gives us our f of x equal to integration of x, 1 is x plus the integration of 2x to the 1/2. That's going to give us 2x to the 1/2 divided by 1/2 plus the integration of 1 over x is the natural log of the absolute value of x plus c. We can clean up this fraction, 2 divided by 1/2. We can multiply by the reciprocal. So we get x plus 4 x to the 1/2 plus the natural log of the absolute value of x plus c. And that gives us a nice, clean final answer. In our last example for the day, we're going to get nice and ugly. So notice we have an x minus 1 squared, and we also have a 1 plus 1 over x, and we're going to multiply those two quantities together. With this, at this point in time, all we can do is multiply it out. If I multiply x minus 1 squared out, we have x squared minus 2x plus 1. With the 1 plus 1 over x, I can find a common denominator, which would be x plus 1 over x dx. We can think of this now as two fractions being multiplied together, because this is over 1. In that case, we multiply the numerators together, and we multiply the denominators together. So this simplifies. I can also go ahead and distribute out the numerator. Distribute. We got x to the third plus x squared. If I distribute the x to the second through. Multiplying the 2x through, the negative 2x, I get negative 2x squared minus 2x. And I'm going to distribute the 1. So plus x plus 1, that's all over this denominator of 1 times x, which is x dx. Now, I can go ahead and simplify the numerator by adding like terms. So I have x to the third minus x squared minus x plus 1. And since I'm going to have to go ahead and decompose this, or break up the fraction, I'm going to go ahead and put each of my terms over x. And I'm going to guess some of you can probably go ahead and do that on your own and skip this step as well. Simplifying this integrand, we have x squared minus x minus 1 plus 1 over x dx. Now we can go ahead and integrate using our power rule. So x squared gives us x to the third over 3 minus the integration of x is x squared over 2 minus x plus the natural log of the absolute value of x plus c. The only other thing that we can do would be to find a common denominator again. Our common denominator would be 6. So our x to the third is going to get a 2 multiplied to it. Our x squared is going to get a 3 multiplied to it. Our x is going to get a 6. And our natural log of x is going to get a 6. To that, we're going to add our c again. Remembering we're leaving that c on the outside there. It's going to be very fluid in the days to come. Now, the only other thing that we could again see is that 6 come up to our exponent. So we have 2x to the third minus 3x squared minus 6x plus the natural log of x to the 6th all over 6 plus c. Remembering again, if I take the absolute value of x to the 6th power, that's always going to give me a positive value. And there, my friends, is f of x. Happy integration.